Alright, now let's look into another techniques on solving the integration, which is when we are dealing with partial fraction. This section demonstrates a method to integrate any rational function, which is a ratio of polynomial, by expressing it as a sum of simpler fraction, or called partial fraction. And to illustrate this method, observe that by taking fraction uh, 2 divided by x minus 1 and 1 over x plus 2 to a common denominator, the expression become something like this. If we, we multiply in here, 2 to the power of x plus 2, and then here, negative 1 over x minus 1, and then multiply in that 2 together. Okay, so you can expand it, it become 2x minus x. It become x. 2 times 2, 4. 4 plus 1 will be 5. And then you get this. So if we reverse the procedure, we see how to integrate the function on the right side here. With the following equation. So let's say I take the integration of this part. So it will be equivalent to taking the integration like this. It will be the same, because this is how you expand it. This is if in terms of partial fraction. Okay, but if you want to solve this directly without changing it to the partial fraction, it's kind of difficult to do it. So normally when we have the polynomial in terms of the fraction like this, and the first one like this function, px divided by qx, doesn't matter whether the px is it's just a linear like this, or quadratic function like this, any polynomial divided by another polynomial, and we can solve the integration by simplify it into partial fraction format. Okay, so let's look at the example here. So what we do when we have the function as shown in here, in terms of the fraction, and we solve it by conducting the division of that fraction, and then we solve it, we make it simpler as shown in here, and then we solve the integration by taking integrate it, and you get it in terms of the ln. For example, like this example 8.7, you have what we call x to the power of 3 plus x divided by x minus 1. So first of all, you need, you see, this is the numerator. Numerator. This is the denominator. Okay, so you see that the numerator here, the top part here, is higher order, higher degree than denominator, because this is to the power of 3, this is to the power of 1. So what we do when we have the numerator degree higher than the denominator, we perform the long division first. You can perform long division using calculator. Actually, it's quite fast. Please search on YouTube on how to do long division using calculator. It will be faster if you know how to use calculator rather than you do it manually. But in this example, I show it manually on how to do it. If you remember the long division of this polynomial, let's say x to the power of 3 plus x, we need to divide with x minus 1. Let me rewrite. X minus 1. Okay, so in order for us to get x to the power of 3, we need to multiply with x power of 2. So x power of 2 multiply with x, you get x power of 3. X power of 2 multiply with negative 1, we get negative x power of 2. Okay, so we need to minus this. Okay, so x power of 3 minus x power of 3, you get 0. 0 minus x power of 2, you get x power of 2. Okay, x minus nothing will be x. So you live with x like this. Okay, alright, now in order for me to get this x power of 2 here, x here, I need to multiply with x. So I will get x power of 2, x multiply with x power of 2, x multiply with negative 1, I get minus So minus x, okay, negative, right, minus 8. X power of 2 minus x power of 2, I get 0. X minus minus become plus, you will get 2x, so here x minus 1, I want to make it negative. I want to remove 2x here, so I have to multiply with 2. 2 multiply with x, you get 2x. 2 multiply with negative 1, you get negative 2. So 2x minus 2x, I get 0. 0 minus minus plus 2, I get plus 2. Okay, so the answer will be x power of 2 plus x plus 2 plus 2 divided by x minus 1. Okay, so that's how I get this one. Okay, that's how I get this terminology. Alright, so now if we leave it with this, it's quite easy for us to solve. This one, you do integration, it will be x power of 3 divided by 3. Negative and negative here will be positive here. So this is positive actually. Positive x power of 2 divided by 2 plus 2x plus 2 ln x minus 1. Plus c. Okay. Alright. So this is how you solve the function that has the fraction like this. So a theorem algebra guarantees that it is always possible to do this. So first let's look at, there are 4 cases. Number 1, the denominator qx is a product of distinct linear factors. Number 2, qx, which is the denominator part, is the product of linear factors, some of which are repeated. Qx contain irreducible quadratic factor, none of which is repeated, or qx is repeated irreducible quadratic factor. Okay, there are 4 cases like that. So let's look at the first one, the first case, where qx, meaning that the denominator is a product of distinct linear function, which is a1x plus b1 multiplied with a2x plus b2. So this is a product, multiply, but then in terms of distinct linear factor, linear, just power of x, power of x, power of x. Alright, let's look at this example 8.8, where you have the first case where the denominator is actually a product of distinct linear factors. Okay, let's look at this example in here. So you have the denominator. This is the px, this is the qx. Okay, let's look at the qx first. The qx here, qx is actually 2x power of 3 minus 3x squared minus 2x. Okay, so let's factorize the x outside here. So you leave it with x here multiply with 2x squared plus 3x minus 2. So you can factor this part. When you factor this part, you get 2x minus 1 x plus 2. So if you multiply in all here, you will get this function. Alright. Now, I insert the qx back here into here. So I will have like this. X squared plus 2x minus 1, which is the px just now, and the qx, instead of I wrote it down as here, now it become the factor like this. Okay, so you can how to say, segregate this, because if you look at here, this is the product at the bottom part, denominator part. This is the product, because it multiply with each other, of a linear function, x to the power of 1, 2x to the power of 1, x plus 2. It's all linear. So what you can do a partial fraction like this, where a divided by x plus b to x minus 1 plus c x plus 2. Now we make it left and right the same. So here I want to make it like this. So you need to multiply in all here. So a multiply with 2x minus 1 x plus 2 plus b, I need to multiply with x, multiply with x plus 2, and then plus c, I need to multiply with x to x minus 1, and all divided by x to x minus 1 plus, x plus 2. Okay, so now the left side, the right side is the same as the left side. So you expand this part, this is the part that I just did, so you expand this part, you will get in terms of x to the power of 2, in terms power of x, and no just as constant. So you replace it back here. So 2a plus b plus 2c is equivalent to 1x2, 1. 3a plus 2b is equivalent to 2. And then negative 2a equivalent to negative 1. So from here, you know that a is negative 1 over 2. Okay. When you know this one, a is equivalent, a is 1 over 2 lah. Because negative, 1 over 2. So when you know the a, you replace the a here. Here and here. So you will get two equations. And when you get the two linear equation, you can solve what's the value of b and c. Okay. So at the end, you will have, insert it back. You need to integrate a divided by x plus b divided by 2x minus 1 plus c x plus 2. So you replace with the value a, b, c that you found just now. You will be like this. Half 1 over x, 1 over 5, multiply with this, and so on. So you will get the answer when you integrate. You will get the answer as shown in here. So the middle term here, you can use this. U replace with 2x minus 1. Du is 2dx. dx is half du, and then you replace it back here. You will get 1.5 multiplied with 1 over 2. Alright, that is the first case where we have the denominator qx is a product of distinct linear factor. Now, if we have the qx now, the denominator part, which is the bottom part of the fraction, is a product of distinct linear factors, some of which are repeated. Meaning that the top part, you repeated like this. There's another power of 2, power of 3, power of 4 like that. Okay, let's look at this example. Alright, find x power of 4 minus 2x power of 2 plus 4x plus 1 divided by x power of 3 minus x power of 2 minus x plus 1 dx. Sorry. If you do long division, if you do long division in here, let's do long division here. X to the power of 4 minus 2x power of 2 plus 4x plus 1. We need to divide with x to the power of 3 minus x power of 2 minus x plus 1. In order for me to get the x power of 4 here, I have to multiply with x, right? So x multiply with x power of 3, I get x power of 4. X multiply with negative x 2, I get negative x3. X multiply with negative x, I get negative x power of 2. And then plus x, negative. Okay. So x power of 4 minus x power of 4, you get 0. 0 minus x power of 3, I get x power of 3. And then negative 2x plus 1, I get, plus 1x2, I get x2, negative x2. And then 4 minus x, you get 3x. And then 1 minus 0, I get 1. So in order for me to get x power of 3 also, this one also x power of 3, I have to multiply, I have to plus 1 here. So x1 plus x power of 3 minus x squared minus x plus 1. So x power of 3 minus x power of 3 is 0. Negative x power of 2 plus x power of 2, you get 0. 3 plus x, we get 4x. 1 minus 1, you get 0. So the answer will be x plus 1 plus 4x divided by this thing. Okay. That's how you get this. Okay. Alright, so let's look at this part first. Okay, change color. Let's look at this part first. So x power of 3 minus x power of 2 minus x plus 1. This one I can factorize as this. So here also I can even factorize as x minus 1 x plus 1. So there's a repeated x minus 1 here. So in order for me to have this, I will have instead of just now, just now it's not repeated, so I will be a divided by x, this one, and second one. Okay, now it is repeated. Okay, so you have this part and then this part. Okay, alright, so now it's repeated. So if it's repeated, you have to do it like this. A x divided by x minus 1 plus another b x minus 1 power of 2 for this one, and then another part for x plus 1. And then you multiply them together, and so on, and then make it equivalent. So here, if you multiply in, you will get a x minus 1 power of 2 x plus 1. For this one, you multiply x minus 1 and x plus 1. And then when you see, you multiply with this one and this one. Then you expand it like this. Okay. The below part you multiply, the below part you multiply all them together. 3 of these multiply together. So you will get same as this. Okay. Okay. Let me. Alright. And then when you solve it, you will get the x plus 1 at the bottom part. At the top part as well, and then you can remove it all together, and then you can make left and right become the same, and you will obtain that a is equivalent to 1, b equivalent to 2, c is equivalent to negative 1. Then you replace back in here. So you will get this one. X plus 1 plus, instead of 4x divided by this, you replace it here. 1 over x minus 1, 2 over x minus 1 over 2, negative 1 over x1. Alright, so you will get, here is this one, x power of 2 over 2 plus x plus ln x minus 1 minus 2x minus 1 ln x plus 1. Here you will get this one. Okay, plus constant k. Right? So you can try the exercise here, and you should get the answer as given in this. Alright, that is for the qx that is a product of a linear factor, but there's a repeated. Now, what if the third case where you contain qx contain the irreducible quadratic factors, none of which is repeated? Okay, imagine like this, if you have the denominator qx as a factor of the polynomial ax squared plus bx plus c, and the b squared minus 4ac is actually a negative number, then in addition to the partial fraction in the previous equation, now the expression of rx over qx will have the term of this form. So you have, let's say, you have the quadratic function. Just now it's just linear. So everything you divide linear, okay? Linear. Here linear, linear, linear. Now the below part is actually you have the polynomial, the quadratic function. And when you check the b squared minus 4ac, 4ac, you will get negative value. Okay? So the way to solve it is you make a partial fraction. So it become ax plus b here. Now it reduce one order here. For example, where a and b is actually constant to be determined, the term in equation 7 here can be integrated by completing the square if necessary, as shown using this kind of formula. So let's say we look at this example here. This function, the px and the qx is both quadratic function, and the numerator is not less than the degree of the denominator. So if we do the division, so if you do the long division, plus 2, and then you divide by 4x plus 3, so you get this one, you have to multiply with minus 4x plus 3, so you will get here x minus 1, so that's why you get like this, so for now when you have this format, now let's solve for this polynomial, so you can do it like this, if you look at this polynomial, which is 4x squared minus 4x plus 3, so you take b squared is negative 4 power of 2 minus 4 times 4 multiply with c, which is 3, so you will get 16 minus something, bigger than 16, so you will get this one as negative value, so due to that, you can complete the square like this, where you have, you factorize it between in this term, alright, this one you will get, for this one you will get 4x squared minus 4x plus 1, and then you add another 2 lah, here, so that it become like this balik. Alright, now what we do substitution, so let's say u is 2x minus 1, du will be 2 dx, and x will be half u plus 1. So now we put it back here, and so 1 plus x minus 1 divided by 4x squared minus 4x plus 3. Now x is this one, you replace it here, and then minus 1, and then 4x squared here is 2x, 2x minus 1, u is 2x minus 1, you will replace it, it become u squared, this one, 4 sini, tolak, 4x plus 3, it will be equivalent to 2x minus 1 power 2 plus 2. So this one is u, right? So u squared plus 2, this one replace here. Alright, so you leave it with this function, and here is actually u, this is one term, another term will be this one, so x plus 4 u divided by u squared plus 2, and then here is 1 over u squared plus u, so if you have this format, this is the same as this, okay, you have to replace, the solution is 1 over a, x over a, so same lah, x power of this one is u power of 2 plus square root 2 power of 2. You will get this format, so that's why it become like this, 1 over a now is square root 2 tangent inverse x divided by square root of 2 plus c, and then this one is straightforward lah, you can replace v equivalent to u power of 2 plus 2, dv will be 2u du, and then u du is equivalent to dv over 2, and then you integrate u du, you have dv 1 over 2, and then the top part you will get v, so you integrate, you will have this one lah, okay, alright. Okay, at the end, this is the final answer that you will get. That is for the second case. For the third case, where you have, for the fourth case, that is the third case. Now the fourth case, where the denominator contain a repeated irreducible quadratic factor. So if qx has the factor of a x squared plus bx plus c, and then the power of r, and when you check the polynomial, b squared minus 4ac is negative number, so you have to express in terms of this partial fraction, depending on how many the composition of rx over qx. Each of the term in equation 8 can be integrated using substitution or by first completing the square if necessary. So this is the example, you have the fraction where now you not just have the repeated, but then you have the quadratic here, and then if you do the quadratic here, b squared minus 4ac, you will have b squared 0 minus 4 times 1 times 1. So you get negative 4, which is the negative number. Okay. So and then it is repeated to the power of 2. So you have to translate it to the form of partial fraction decomposition. It become like this. Repeated, so you need to do it twice. Do it twice, but now it's quadratic, so you add bx here, dx here, and then you do the same lah. You multiply in all together and you make the left and right become the same in order for you to determine the value of a, b, c, and d and e. Okay. After that, you replace the value of a, b, c, d, e that are known previously, and it becomes something like this. So that is easier to solve. So here you use this formula, this one, and then here is using substitution. You make u equivalent to 2, you make u is equivalent to x squared plus 1. Here you use tangent inverse just now, and here also you can use this substitution style. So you leave it with this as an answer. Alright. Okay, improper integral, perhaps I'll do another video, or I do it in the class.